Good morning, boys and girls. So today we're going to continue talking about volume, except we're going to take volume to the next level. We're going to start looking at what happens when a figure isn't a perfect prism like this. What happens when there's pieces and parts that are missing? How do we solve that? Okay. So before we get into the textbook lesson for today, I'm going to do like a throwback to fourth grade so we can review funky figure area or rectilinear area really quick, and then we'll get into today's lesson in the book. Okay, so what I'm getting ready to write now, you do not need to write down unless you feel like you need to. This is really just kind of to help us build connections in our brain of what we're going to be doing with volume. Okay, so in fourth grade, you would come across figures that look like this when you were learning about area and perimeter. In fact, you did this in third grade too, or third grade math, I should say. So these are called rectilinear figures. I call them funky figures because they look super funky. If I were to tell you, let's say this was like a 5, 3, I don't know, 4, yeah, that's good. So what if I gave you this figure and told you to find the area? What's the first thing that you would do? Hopefully you said you'd probably split it either here or across the other way. So either way you could do it. But we have to take this funky figure and we have to split it apart into two separate rectangles. Okay. From those two separate rectangles, what would you do? Well, we'd find the area of this one. 8 times 5 is 40. 4 times 3 is 12. Now what do we do to find the area of the whole thing? We're going to add that 40 plus that 12 because this particular figure is made up of a rectangle that has an area of 40 and a rectangle that has an area of 12. So if we combine those two, we get this entire figure with an area of 52 units squared. Okay, so let's kind of take that same idea. We're going to apply that to volume. So I need you to go to page 961 with me, please. Okay. Today we're talking about composite figures. So composite figures are kind of that same idea as rectilinear figures for area, where we have more than one prism that are combined to make this funky looking shape. Okay, so again, I have Fancy Pants snap cubes with me. You may or may not have something like this. If you do have something like this, you are welcome to build these with me. You'll just have to pause the video to build them. If you don't have anything like this, I'll hold it up so that you can see and still participate along with us, okay? So looking at this figure, one way that we can solve these problems is we can count the number of unit cubes that make up this figure. Because remember, volume is how many unit cubes can we fit inside of a figure with no gaps and no overlaps. So we can go through and we can count the number of cubes in here, right? So if I count the bottom layer, I've got 1, 2, 3, 4, 5, 6, 7, 8 cubes. I'll write that in. Oops, still on the eraser. We've got 8 cubes. Okay, let's count the top layer. So this top one has 1, 2, 3, 4 total cubes. So altogether, how many cubes did we use to build this figure? 12 cubes. Which means since it took us 12 cubes to build the figure, that means our composite volume or our total volume is 12 cubic centimeters, okay? But what happens when you either don't have the unit cubes drawn out for you, or we start getting into numbers like 20 and 35 and 72? What happens then? What do we do, okay? I'm gonna erase and pause the video. Meet me on the next page. All right, so let's think of this a different way. Let's kind of think of it the same way that we would think about that problem I just showed you with area and perimeter, or sorry, not perimeter, area. So this particular composite figure is made up of two separate rectangular prisms. Well, we have the formula for a rectangular prism, right? Length times width times height, or you can also think of it as base times height. So let's actually make this whole funky looking thing. Let's break it apart into the bottom layer and the top layer. Well, I know how to find with the formula the volume of this layer, and I also know how to find the volume of this layer. Then if we can combine them, we can find the total volume of all of the entire figure, okay? So let's start with this top layer here. So it says length times width times height. So let's use what we know about that. So we've got length of 2 width of 2, and a height of 1. And 2 times 2 times 1 equals 4. Remember, the volume's 4 because 4 unit cubes make up this figure, okay? Then let's look at our bottom layer. Oh, let me fill this in first. Hold on. So the volume of the top prism is 4 cubic centimeters. There we go. Now we're ready to go to this one. So for this bottom layer, we've got a length of 1, 2, 3, 4 cubes. We've got a width of 2. We've got a height of 1 again. So the total number of cubes in this figure is 8, which makes our volume of the bottom one 8, right? So using that same idea of taking 4 and adding it to the 8 gives our total volume of 12 cubic centimeters, which is the same thing we got when we sat here and counted all of the different cubes, okay? So the volume of the composite figure is 12 cubic centimeters. Here's what I need you to do. I need you to pause this video and complete the talk about it questions, and then come back when you're finished, or replay start the video again when you're finished, so that we can talk about your answers. All right, so number 3 says, explain how you can use addition to find the volume of a composite figure. Well, we know that volume is length times width times height. There's no addition there. But if we add the different prisms that make up a composite figure, if we add all their volumes together, we can find the total volume of that figure. That's how addition comes into play for composite figures, okay? Number 4, explain how you would find the volume of the composite figure shown. So your answer might be a little different from what I'm thinking. In my mind, I look at this figure and I go, okay, I notice two kind of layers, right? I notice that bottom layer, and then I notice the top one. There's some missing from the top one. So my options are either subtract those 2 from the volume of that prism, or I could sit here and count all the cubes. I'm not one for counting. I like the volume formula more. So for me, I would end up doing, I'm gonna put V for bottom volume. So I would say 1, 2, 3, 4 times 1, 2, 3, 4 times 1. So the bottom volume is made up of 16, it doesn't give us a unit, so units cubed. Then I'm going to call that one the top volume. I'm going to pretend like those squares are there while I figure this out, or those cubes, I should say. So it would be a length of 4. It has a width of 1, because there's only 1 cube right here, and then a height of 2, because we have 2 cubes here, right? So then all together, we would say this one's made up of 8 cubes. However, how many of those cubes are missing? 2 of them in the middle, right? There would be 1 here, and there would be 1 here. So minus 2 gives us 6 units cubed. So all together, we would say 16 plus 6 gives us 22 cubic centimeters. All right. I'm going to pause. Meet me on the independent practice page so I can explain something. All right, guys. So on your independent practice for today, here's your tasks. You are going to complete page 963. It's not very long at all. It shouldn't take too long. Then we need to check in and make sure that you are understanding how to use the volume formula, not necessarily with composite figures since we just started that today, but with just regular rectangular prisms. So once you finish page 963, you're going to do the volume practice on Study Island as just a check-in so we can make sure you're getting what you need to be getting. And then finally, if you have time, if it doesn't take you too long, then you'll be working on your vampire mystery. Remember that vampire mystery is going to go through the rest of this week. It'll be due on Friday. So if you don't get the chance to do it today, that's okay. You'll just have to do a little bit more tomorrow and Friday, okay? So anywho, on this page, I wanted to point out that it tells you specifically, build a composite figure using centimeter cubes. Those are these. You might not have them at home, and that's okay. You might not even have anything at home that you can build with, and that's also okay. So what you're going to do is you're going to rely on your drawing. So in the My Drawing section is where you're going to just draw a very basic sketch of what the bottom layer and the top layer look like, right? So in this particular one, in this particular one, hold on, I'm going to go make him stop barking. All right, all better. He's not barking anymore. So when I would draw it, I can see that the length is 3. So I would draw 3, and then the width is also 3. Bloop, bloop. This is what the bottom layer would look like if I were looking down on it, right? And the top layer is 3 long, 1 wide. So the top layer would look like this. So you can rely on your drawings instead of actually building the figures to help you with these. Okay, I just wanted to point that out really quick. If you have any questions, of course, let us know, but happy working today.